Okay, I want to go through just one simple solving technique for exponential equations. So let's say we have these exponential equations set equal. Let's have this exponential equation set up here. First thing I'm looking at is that we have 6 here and 6 here. The bases are the same. So I guess my only argument is if this was 6 to the fifth power and this was 6 to the fifth power, they'd be equal to each other. Isn't that true? If what we see in purple, if the number in purple turns out to be the same as the number over here in purple, then we'll have 6 to the same power on each side. So that will be true, won't it? If you're buying that, then what I'm asking you to buy next is that all we have to do now is look at this part of the equation. So now I just said 7 minus x is equal to 2x plus 1. And I just solve. I'm going to move stuff around. I'll get 3x is equal to negative 6. I hope that you can see that. And then, of course, x is equal to 2. X is equal to 2. And if you don't mind, I'm going to choose this color for my 2. X is equal to 2. Well, here's x right here, right? So it said x is equal to 2. So here's 2 here. And say x is equal to 2. So here's 2 here. And let's see if that's not true. 7 minus 2 is 5. So we have 6 to the fifth. All I do is just the simplification of this work here. 2 times 2 is 4. 4 plus 1 is 5. So equals 6 to the fifth. So reflexively, that's just true, isn't it? Okay. I think that's I think it's an excellent example. But here's another example that's not quite as obvious. And this example looks like this, is 1/2. So let's call this example 2. Example 2. And example 2 has nothing to do with this stuff here. So example 2 is 1/2 raised to a power is equal to 2 raised to a power. And if you don't mind, the power we're going to raise them to is the 6 minus x power here. And this one is not raised to a power, so we can assume that it's the power of 1, isn't it? Well, here's the problem, that the bases aren't the same. We have a base of 1/2 here, and we have a base of 2 here. So the question is there some way I can rewrite 1/2 in base 2? So I think that 1/2 is equal to 2 to the negative 1 power, isn't it? Just to show you that. Right? It's 2 to the negative 1 power. So I'm going to replace this 1/2 with 2. So here's my 2 here. But I can't just change it to 2. I have to have an equivalent. This 2 here somehow or another has to equal 1/2. So I'm going to take this negative 1. And just want you to consider this for a second. If you saw 2 raised to the negative first power, wouldn't you automatically take the reciprocal of this thing to get rid of this? And wouldn't you have 1/2 again? Right? Is equal to, here's that other 2, and here's to the first power. Now look, we're not done because this thing was already raised to this power, wasn't it? So it's going to do this to the 6 minus x here, right? Going to distribute this through here and here. And let's see what this looks like. Now we have 2 to the negative 6 plus x power is equal to 2 to the first power. Right? Now we have same bases. And hopefully you can see this. And this, right? Check the bases are the same. And we're going to set this equal to this and then solve. And let's see if that doesn't work. So we get negative 6 plus x is equal to 1. Right? And we'll solve. We'll add positive 6 to both sides, and we have x is equal to 7. So x is equal to 7, right? So let's see if that works. There's no x value here. Let's try this. X is equal to 7. Take this x out, if you don't mind. Take this x out right here. And we'll put in this 7. X is equal to 7. Test that out. Negative 6 plus 7 is 1. And doesn't 2 to the first power equal 2 to the first power? Something to think about. We haven't even talked about this in class yet. And we're going to keep working through these examples. And we're going to go back and we're going to keep proving that they're true. So we're not only going to solve. We're not only going to change bases. What we're going to prove. This one was real weird. It was 1/2 equals 2. What do? We express this 1/2 in something called base 2. And 2 to the negative first power is, in fact, 1/2. Took this negative 1 right here, put it here, and distributed it through. So I hope this was helpful. I know it's a tiny bit confusing. Hang in there. We're just starting this, right? Okay. Nice graph, right?